In this video I'm going to talk about partial derivatives and how how we have to use or how we can use partial derivatives. So we start with the definition. So one definition for partial derivatives is this one, for example, f of x a b is the limit when h goes to 0 of f a plus h b minus f a b divided by a. So the same as the derivative of one function with respect to x, but um, here we are dealing with two variables, so this can be x and this can be y. So we have also the partial derivative of y, so which is the limit when h goes to 0 of f a b plus h minus f a b divided by h. So we can write this here for partial of f, partial of x. So partial of f, partial of x, and this one is partial of f, partial of y. First of all, I'm going to do some exact derivative of one function. For example, if we have uh, f of x, this is an example. For example, if we have f of x, which is equal to c times x squared plus sine of x times, so this is times c squared, where c is constant. So when we do df by dx, we have d by dx cx squared plus d by dx of sine x times c squared. So the when we have the constant here, for example, the constant goes out, so we can write this as c. So this is the constant c times d by dx of x squared plus, here is the c squared, the constant, so the constant goes out, sorry, c squared, and then d by dx of sine x. So the derivative of this one, so c times derivative of x squared is 2x plus c squared derivative of sine x is uh, cosine x. So this is the exact derivative, how we do the total derivative of one function. But if we have, for example, one function as f of xy, so we have, for example, x squared times y squared plus x squared plus y squared plus c times x squared times sine of y. So we have to do two parts. So if you want to compute, so I'm writing this. If we want to find df, so this is the exact derivative. Sorry, maybe this color is not good. We have to do like df is partial of f partial of x, so we have to differentiate this one with respect to x, times dx plus partial of f partial of y times dy. This is the exact derivative of this function df. But partial of f partial of x means that we take the derivative with respect to x, and y is taken as a constant. So when we take the partial of f partial of x, y is constant. So we do like this: partial of f partial of x partial of x. We have, for f we have x squared times y squared plus x squared plus y squared plus c times x squared times sine of y. So I can do it like this. So partial of x squared times y squared plus partial of x of x squared plus partial of x of y squared plus partial of x of c times x squared times sine of y. So with this first one, partial of x, so here y squared is a constant, so y squared is before, so constant, and we have to take partial of x squared plus partial of x partial of x squared with respect to x is we leave it like that, plus, so we have taken that epsilon is the constant, so epsilon is constant, so the derivative of constant is 0, so this part is 0, plus we have c is a constant, sine of y is a constant because here we have y, so c times sine of y goes before, times we take the partial of x squared. So we have equal with y squared, so for this one, times 2x plus 2x plus this one is 0 plus c times sine of y times 2x. So this one is 0, so we can do it 2x, which is y squared plus 1 plus c times sine of y, sorry. So this is the derivative of f with respect to x, which we call partial derivative. Okay, now I'm going to do the derivative of f with respect to y. So let me rewrite the function, which is x squared times y squared plus x squared plus y squared plus c times x squared times sine of y. So now partial of f partial of y is partial of y, x squared plus y squared plus sorry, here is times, plus x squared plus y squared plus c times x squared sine of y, and partial of y, x squared times y squared plus partial of y of x squared plus partial of y squared plus partial of y of c times x squared times sine of y. So now when we take the derivative of f with respect to y, now x is constant. So we have x squared times partial of y squared plus, this is the constant, this is 0, plus 2y plus, so the constant here is c times also x squared times, so we have to take partial of y times sine of y, which is x squared times 2y plus 2y plus cx squared times the derivative of sine of y with respect to y is the cosine of y. So this is the partial of f, partial of f, partial of y. Maybe I can take some other functions. For example, I can take this one. Sorry. So I can do f of x, y, sine of x times y. So the angle here is the product of two variables. So maybe sine of theta is equal to x. So theta is x times y. So we have to do partial of f, partial of x, which is partial of x sine x times y. First of all, we have to take the derivative of sine as a function and then times x times y, the derivative. So derivative of sine x and y, x times y, is cosine x times y times, we have to do the derivative of this argument here. So the argument is x and y. We have to do the partial of x times y, which is so here y is the constant, so y times partial of x times cosine x times y, which is y times this one here is 1 times cosine x times y. I can do partial of y as well, so which is partial of y sine of x times y, so which is cosine cosine x times y, but now we have to take partial of y x times y. So now x is a constant, which is x partial of y cosine x times y, which is, this is 1, so x times cosine x times y. So this was other example. Maybe I can do, for example, we have g, we call that g x y x squared times e in a power x times y. So we have partial of g partial of x, partial of x squared times a. So here we have to use a times b derivative, which is a derivative times b plus a times b derivative, where a for us is x squared and b is e in the power xy. Now, partial of x of x squared times e to the xy plus x squared times partial of x in e in the power xy. So partial, the derivative of x squared is 2x times e in xy plus x squared times the derivative of e to the x is e to the x. So now we have times e to the x times y, but we have to take partial derivative of this argument here, x times y. Now 2x times e to the xy plus x squared times e to the xy times y is a constant, goes, so y partial of x, which is 1. The in the end we have 2x times e to the xy plus x squared times y e to the xy. So we have x e to the xy, we have 2 plus x times y. So this is the partial of g partial of x. I hope you understand this one here. So partial of x. Now I have to do the derivative of with respect to y. So partial of g partial of y. In this case, we don't have to use a not chain rule. We don't have to use product rule because in the first part we don't have y. So for us now, x is constant. So this x goes way before. So we have partial of y, x squared times e to the x y. X squared goes before, partial of y, e in the power xy. We have x squared. Now we have to differentiate this function all e to the xy, but when we have the complicated argument here, for example xy or x squared or whatever, we have also to take the derivative of this argument here. So the derivative of e to the xy is e to the xy, but we have to take the derivative of this this argument here, which is xy. So now the x is a constant, so x squared times e to the xy times x, which is x third in x power So maybe I should do one more example in this part. For example, if we have f of x is equal to sine of x. So take the derivative of this, df by dx. d by dx sine of x. So the argument is x now. So first we do the derivative of sine x is cosine x times d by dx of this argument here, x, which is 1. This is the reason why we don't write this. But when we have complicated arguments, for example, when we have f of x, for example, sine of x squared plus x squared, sorry, only x squared. So now when we do df by dx, we have d by dx sine of x squared. So the derivative of sine x squared is cosine x squared. But we have to take the argument in derivative, which is x squared. So 2x times cosine of x squared. In every single case we do the derivative of argument, but when we have one variable, for example, sine x, e to the x, cosine x, tangent of x, and those things, we don't do because the derivative of x always is 1. So this is the reason why we don't show. For example, if you take f of x, whatever, ln of x. So df by dx is 1 over x. So, but when you take f of x, ln of, for example, x squared, so df by dx now is 1 over this x squared times d by dx of this x squared. So 1 over x squared times 2x, which is 2 over x. This is obvious because f of x can be written as 2 times ln of x. df by dx is d by dx of 2 times ln of x. 2 is a constant, goes before, times d by dx of ln of x, which is 2 times 1 over x. Same here, same here. So those were partial derivatives. In other video I'm going to do partial derivatives in more detail for chain rule, because sometimes we need chain rule, and we need some the chain rule is the method. For example, if f is a function of x, y, but x also is a function of t, for example, time, and y is also the function of t. So when we compute df, partial of x dx plus partial of y dy, so we have to rewrite this in terms of those variables here. Partial of f, partial of x, partial of x, partial of t, and so on. But those we do in other video. Thank you very much.